Let's get to work and let's start with chapter 1, how to find anything instantly. So this is the concept that I want you to have at the back of your mind while we work on the algorithms for this chapter. So imagine this. You're a customer support agent at an online store. Someone calls in and says, "Hi, my name is Tom. I placed an order last night. Can you help me check it for me?" You open your system and you don't scroll through a long list of every customer. You type in Tom's email, press enter, and boom, his record shows up instantly. You don't realize it, but you just used one of the most powerful tools in computing, a hash map. Why this matters? In the real world, if you had to look through a list of 10 million customers one by one every time someone called, you'd quit by lunch. But computers can't guess who Tom is. They need a system, a clear set of steps to find what you need fast. This is the first building block of algorithmic thinking. So your job is to find someone's information by their label, like email or ID, and to do it in under 20 milliseconds, even if there are 20 or 10 million users. So the way the machine thinks of this is they make a table where they store your customers in a simple format, like a hash map. We have a relationship between the email and the customer profiles. And this is basically a fancy name for a label for a thing. Just keep that at the back of your mind. And step 2 is jump to that label. So when someone types in an email, the system doesn't scan. It doesn't go through the 10 million users that you might have in your database. It jumps directly to the correct row. Kind of saying go to locker 214. You don't need to check every locker. You go straight to the one with the right number. So now what's the price of this? Once again, this is another thing that I need you to keep at the back of your mind throughout this course and throughout your algorithmic journey. Every algorithm has a cost, and look at it as a price tag on speed and memory. Now, a hash map, the cost is very low because hash maps are fast. It's like flipping straight to the right drawer, and this is constant time. It means the same amount of time even as the list grows. Now, in terms of memory, you need space to store all those label thing pairs. And that's O of n, meaning it is linear. Every entry is a person, which means the more people you have in the list, the longer it's going to take. And this is totally worth it when you're working with millions of people.